Most of us picture cognitive decline as an inevitability. We imagine our brains on a slow, smooth downward slope, a gentle, unstoppable fade that comes naturally with old age. But the data tells a very different story. If we look at Alzheimer's disease, the cases caused by purely inherited genetic mutations make up less than 5%, and possibly as little as 1% of total cases. Our cognitive fate is rarely hardwired into our DNA. The medical community's understanding of brain health is changing rapidly. Based on extensive research, including comprehensive reviews from the Lancet Commission, experts now accept that nearly half of all dementia cases are tied to modifiable risk factors. And when you factor in broader societal and environmental influences, up to 70% of all dementias may be preventable. To understand how we can prevent that decline, we have to look at how the brain actually degrades. This chart visualizes data from the Adult Changes in Thought study out of the University of Washington. If you track people's cognitive function over a period of years, you might expect to see this standard smooth downward slope, but that is almost never what happens. Researchers found that cognitive function actually drops in sharp vertical steps, and those sudden drops correlate directly with periods of significant illness or physical hospitalization. Brain aging is rarely caused by the slow passage of time. Instead, cognitive decline is driven by the body's failure to recover from sudden, severe health shocks. When you get a severe systemic illness, the damage extends far beyond a temporary fever or fatigue. That infection actively degrades your long-term cognitive baseline, causing one of those permanent step-downs in brain function. We can see exactly how protecting against these illnesses preserves the brain by looking at massive natural experiments in the UK, Australia, and Canada surrounding the shingles vaccine. In these countries, huge groups of older adults became eligible to receive the vaccine on a single date. Because the cutoff dates created such clear before and after groups, researchers could compare the populations directly. The epidemiological data revealed that the groups eligible for the shingles vaccine showed a significant sudden decrease in their overall risk of developing dementia. The leading biological theory for why this happens is that the vaccine has an immunomodulatory effect. It suppresses the immediate shingles infection while also helping the immune system suppress other dormant herpes viruses that physically live on our neurons, preventing them from driving chronic neuroinflammation. This biological defense is also compounded by a behavioral reality. When you are severely sick, you are isolated at home. You are highly stressed, you aren't moving, and you lose critical sensory and social stimuli, all of which accelerates cognitive decay. Avoiding sickness altogether protects your neurological baseline. Keeping yourself from getting a severe infection is a frontline defense strategy to prevent an irreversible cognitive step-down. The second major acute stressor that forces a cognitive step-down is sudden physical trauma, like a concussion or a traumatic brain injury from a fall. This chart illustrates the immediate physiological crisis inside your head after a hit. The moment you suffer a brain injury, there is a massive spike in your brain's energy requirements. But simultaneously, your brain's ability to produce that energy crashes, creating a massive deficit. This flashing danger zone between what the brain needs and what it can produce triggers mitochondrial dysfunction. The cellular power plants fail, and if that gap isn't closed quickly, it rapidly leads to cell death and widespread inflammation. To close that energy gap, neurologists recommend interventions with positive asymmetry, treatments that carry very low risk but offer a high potential to protect the brain when it is most vulnerable. The absolute first phase of the acute concussion protocol is strict temperature regulation. A hot brain requires more energy, so preventing hyperthermia by cooling down immediately is crucial. At the same time, you have to cut off inputs that further stress the system, meaning completely avoiding refined sugars, alcohol, and stimulants like caffeine. The immediate hours following a head hit present a critical metabolic window. Taking control of your brain's environment right away can physically halt the compounding damage before it becomes permanent. Once the immediate environment is controlled, the second phase of the acute TBI protocol involves using targeted nutritional supplementation to force cellular recovery. One of the most effective tools is a heavy loading dose of creatine, which helps restore the brain's depleted cellular energy. Pair that with a highly bioavailable supplement like magnesium glycinate, and you give the brain the raw physiological materials it needs to repair itself. You also have to manage the physical structural damage. This graph shows how introducing high doses of omega-3 fatty acids directly lowers the levels of circulating neurofilament light in the blood, a primary biomarker that indicates active injury inside the brain's neurons. The protocols used to aggressively treat a concussion are really a microversion of the broader, lifelong fight against cognitive decline. Whether it is a systemic illness or a physical injury, your ability to recover depends on your biological baseline. By actively maintaining modifiable lifestyle factors, like protecting your hearing and vision, optimizing your sleep cycles, and staying physically active, you build a deep reserve of resilience against unexpected shocks. By aggressively defending our brains from acute health shocks and providing them with the right fuel to recover, we can actively preserve our functional baseline and dictate the terms of our own aging.